Okay, so good day, grade 8 max size students. For this lesson, we will be discussing about central angles, chords, and arcs of circles. So this is the first lesson for our fourth quarter. Okay, so this will be the lesson for our fourth quarter, the first lesson for our fourth quarter. And as you can see here from the figures that we have here a pond that is in the shape of a circle. Okay, or in a yin yang. Okay, so there you go. We can find chords, central angles, and arcs in different circles. And also we have here the Mall of Asia. So one of its greatest attractions is this eye-shaped building. Okay, so here in Mall of Asia, so that's the arena. Okay, found in Mall of Asia. So there you go, we have this arc there. And also in France, we have here the Triomphe de l'Arc. Okay, so there you go, we have this arc-shaped structure also found in France. Okay, so there are a lot of different structures, okay, mostly circular structures that are formed using arcs, and we're going to dive deep into those details here on our different parts of a circle. Okay, so for the first part of a circle, we have the center point. Okay, so for this circle, it's going to be point P. Okay, so we just name it point P. And pi, of course, is a constant. Its value is 3.14. And as you know from solving the area of a circle, the area of a circle is equal to pi r squared. Okay, and finding the circumference of a circle is equal to 2 pi r. Okay, so that means the value of pi is equal to, if we divide this expression to 2r, so therefore the value of pi is equal to c all over 2r. Okay, c all over 2 times the radius, or c all over d, or the diameter. So this is essentially the value of pi. Pi is equal to, okay, the total circumference of the circle divided by its diameter. And the diameter, of course, is the longest line that we can form in a circle. Okay, and it always crosses the center of a circle. Okay, and the circumference, of course, is kind of like the perimeter. Okay, so we have discussed this in previous topics. So the perimeter of a circle. So the radius is half the diameter. Okay, radius is the half. Okay, the half of a diameter. There you go. And it can only be found in the center. Okay, so the circumference here, okay, so we can't really write the circumference, but if we're given a value, we can compute for the value of the circumference and pi. And the diameter here is rs. Okay, so it's the only diameter. The radius here, okay, so we have 4 radius here, so that's rp. Okay, ps, okay, rp, ps, pd, and pg. So those are our 4 diameters for circle P. Okay, so if you notice, all of them start or have a point P, okay, for the radius, because the radius always starts at the middle. Okay, so then we have the chord. Okay, so the chord is a line segment that is not found on the center of the circle. Okay, so that will be VB. Okay, VB, KY. Okay, so DG can also be a chord. Okay, there you go. So we have a lot of chords inside of this circle. And then we have the tangent line. The tangent line is a line that intersects with a circle at only one given point. So for this one, we have here the tangent line is TU, okay, or line D, lowercase d. Okay, and then we have the secant. So the secant is a line that intersects on a circle at 2 distinct points, okay, and it can go, of course, beyond. Okay, so that's the difference between the chord and the secant. A chord is just limited inside the circle. A secant, okay, so it can go beyond the circle. It can go externally. Okay, it can go from left to right of a circle. So for this one, we have the secant, which is QM. Okay, and then we have the arc. Okay, so the arc is, of course, an arc in a circle is a specific part of the circumference of a circle. So for example, here we have VB. Okay, so that's an arc. Okay, and later we will distinguish the 2 main types of arcs. Okay, so we have the minor arc and the major arc. So VB is actually a minor arc. Okay, So later we'll know the difference. And we have RTS, okay, so arc VB. Okay, so we draw arcs using this symbol, kind of like a rainbow symbol, but there's only one, okay, one arch, or kind of like an arch. There you go. So we have here arc VB, arc RTS, arc RDS, RTS, arc RDS, arc GS, and so much more. There are so many arcs that you can find on this circle. So just always remember that an arc is a part or a section of the circumference of the circle. So if you have the circumference, okay, so we can identify the arcs by drawing points between them. Okay, and then we have the sector. So the sector is kind of like an area on a circle. So for this one, we can have a sector. Let's use a different color so that you guys can see. Okay, so for this one, we have a sector RPD. Okay, so that's a sector. Okay, so RPD. Okay, so it's an area. It's an area that emanates or can be found on a circle. So we have here sector RPD. Okay, SPG. Okay, DPG. Okay, so that's a sector. Okay, so we have their three sectors, and also this one. This can be a sector RTS. Okay, and we don't put any symbol above them. Okay, and then we have the segment area. So the segment area is the area of a given segment. So how do you define a segment? Okay, so this is a segment. Okay, so a segment is a part of a sector. So when you have a sector and you divide the sector, and you have created two areas, the area of the triangle and the area below the triangle. So the area found below the triangle, so that is the segment. For this one, we have segment DG. Okay, and if I also happen to draw another line here, let's say for example I drew a line here, so that's GS, so therefore we have here segment GS. Okay, and also if I draw another line here, another chord, so we have here segment RD. So we have here the segments, okay, GS and then RD. And then lastly we have the central angle. So for this figure there's only one central angle, so it's PG. So that is our central angle. So another central angle could be, okay, GPS. Okay, so if you draw here an angle, so there you go, we have here a central angle. A central angle is an angle found in the, okay, or emanates or comes from the center of a circle. Okay, and here you go. So these are some of the parts. So here it's more detailed. We have the center point. Center point is point P. The circumference, the formula is 2 pi r, where pi is equal to c all over d, or the constant 3.1411601 and so forth. Then we have the diameter, which is rs, the radius, which is rp, ps, dp, and pg, the chord, which is vb, dg, and ky. And then we have a tangent line, which is tu, or line D. Then we have a secant line, which is qm, or line n. Okay, so we have here a small n. Then we have arcs. Okay, so there are a lot of arcs. Maybe you can identify some more of these arcs, okay, that are not written here on the screen. So we have your VR, VT, RK, KD, DG, GY, BS, TB, RDB, so on and so forth. And again, when we write them, we always put a hood, okay, or kind of like an arc, okay, an arch all over the letters, the two letters or the three letters. So two letters, for the two letters, that's for the minor arcs. So all of these are minor arcs, these ones, VR, VT, RK. And then the three letters, we only use that for the major arc. So later we're going to see more of the difference of a minor arc, the differences between the minor arc and the major arc. And then lastly, we have your sector DPG. So again, guys, this I'm sorry, the sector is an area. Okay, the area, part of an area of a circle. And then we have the segment area. Again, the segment area is the area found under the triangle of the sector of a circle. So you see here triangle PDG. Okay, so it's part of the sector of the circle PDG. Okay, so the area under that, the area DG. So there you go. So that is a segment area. And then lastly, we have a central angle. Okay, so we have here DPG. Okay, so there you go. So those are all of the parts of a circle. So there are a lot of parts, but you can easily identify them. So they're very identifiable. You can easily pick them, okay, based from their properties. The diameter the diameter and the radius only emanate or start from the center of a circle. And again, guys, the definition of a circle, okay, the formal definition of a circle, it is a figure wherein all of its points found on the circumference are equidistant from the center. So what do you mean by equidistant? Okay, equidistant means that all of these points found on the circumference, so all of these points, okay, all of them are, okay, they have the same distance from the center. So that's why it's called equidistant. Or the other way to put it, all of the radius, all of the radii of a given circle are congruent to each other. Okay, so that's the main implication of that. So when you say something, when a specific figure has points that are equidistant from a given point, so therefore most likely that's going to be a circle, especially if it's the center. Okay, so there you go. So that's the main that's the clue word there. For a circle, we have all of its points found on the circumference, they are equidistant from the center point. Okay, so there you go. So that's why in naming circles, let's say we want to name the circle on the screen, so we are going to name it as circle P. Okay, so we always name our circle using the center point. Okay, so that's how important the center point is on a circle. So we always name it using the circle there. Okay, the center point. Okay, the center point of the circle. Okay. Okay, guys, to continue, so we have here the theorems and postulates about circles, arcs, and their central angles, and also some chord postulates and theorems. So the first one, the circle, its formal definition, again, a circle is a set of all points, okay, a set of all points that are equidistant, okay, from a fixed point, which is called the center. The fixed point is the center, and the fixed distance is the radius. Okay, so there you go. So if we have here a center C, so therefore, if we have here point P, so therefore CP is a radius. Okay, so CP is a radius of circle C. Okay, so there you go. And again, we always name our circle using the center point. Then we have the radii postulate. So all radii of a circle are congruent. So that's one of the main implications of this definition of a circle. So again, if all of their points are equidistant from the circle, therefore, okay, so all of the points found in the circumference are equidistant from the center of the circle. So therefore, all of the radii of a circle are congruent to each other. The central angle, an angle whose vertex is the center of the circle. Again, for example, we have here CDE. So therefore, angle CDE is a central angle. Then we have a minor arc. So the minor arc is the degree measure of a minor arc is always less than 180 degrees. Okay, so there you go. So we have here, okay, so this arc here, DE, okay, the degree of a minor arc is the degree measure of its central angle, and also it's always less than, okay, so another point to take note of, it's always less than 180 degrees. Whereas the major arc, let's say for example, we have here point F. So therefore, okay, the measure of CFP, so let's arc CFP, let's say for example that's 215 degrees. So therefore, okay, let's just say for example it's 215 degrees. Therefore, arc CFP is a major arc, okay, because its angle measurement is greater than 180 degrees. Then we have the arc addition postulate. It's very much similar to the segment addition postulate and the angle addition postulate. If we have here AB, okay, let's say for example we have here AB, okay, and let's say this is circle E. Let's say circle O, okay, and let's say we have here point C. So therefore, if we add here AB and BC, we get arc AC.